Again, welcome to College Algebra. This is System of Linear Equation, lecture number 2. So again, in this lecture, our main objective is solving system of linear equation, which involve 3 equations in 3 variables. In our previous lectures, we solved system of linear equation with 2 variables. And we use the substitution and also the elimination method. In these lectures, the same thing, we are going to use substitution and elimination method to solve system of linear equations with 3 variables. Also, we are going to solve applications that involve system of equations. So we start with the solving systems involving 3 equations in 3 variables. So here again, we are going to use elimination and substitution. And same as our previous lectures, we use elimination and substitution to solve system of linear equation, which involve 2 variables or 2 equations. So the method we are going to use here is that we can choose either 1 and 2, or equation 1 and 3, or equation 2 and 3. Then we are going to eliminate one of the variables. Let's say here we are going to eliminate z. Then if, for example, we choose 1 and 2 and we eliminated z, we can take 2 and 3 or 1 and 3 to eliminate z again. So in this case, we are going to get 2 new equations with only 2 variables, which will be x and y. So now we are going to use our previous method to find the value of x and y, either substitution or elimination. When we get the answer, we are going to pick any of these 3 equations here. Then substitute x and y, then we can find z. So the best way, let's go through the method here. So this is our first example. So what we did here is that we pick equation 1 and 2. And we are going to eliminate z because it's very straightforward. The first equation, we have plus z. The second equation, we have minus z. So it's more easy. So we combine equation 1 and 2 using the elimination method. We are going to get x plus 2x, which will give us 3x. 2y plus y will give us 3y. Then plus z minus z will cancel. 1 plus 8 will give us 9. So now we are going to call this equation equation number 4, which is our new equation. Now here we chose 1 and 2 to eliminate z. So now we have 2 options. We can either take 1 and 3 or 2 and 3 to eliminate z again, so that we get 2 new equations with only 2 variables x and y. So that's our solution again. So here we have 2 equations. And so when we get those 2 equations, we are going to again eliminate the z out. So what we did here is that we decided to take 1 and 3. Again, let's go back. Previously, we take 1 and 2. So we cannot take 1 and 2 no more. Either we take 1 and 3 or 2 and 3. So we took 1 and 2. We eliminate z when we combine using the elimination method. When we combine 1 and 2. This is our new equation. Next time, we decided to take 1 and 3. Or we can take 2 and 3, that's fine. So here, first of all, the equation 5 means we have 3x plus 3y equal to 9. So 3 is divisible. So we can reduce this equation by 3. So we divide 3 by everything. So it's the same as writing x plus y equal to 3 is the same as 3x plus 3y equal to 9. But it's good to use the lowest coefficient, which will be more easy to do our arithmetic operations. So this is our first new equation, x plus y equal to 3. Again, as we said, we use 1 and 2, equation 1 and 2 to get this solution. So now we can use either 2 and 3, or we can use 1 and 3. Here we decided to use 1 and 3. So here we say we now choose a different pair of equation. Again, the key word is a different pair of equations. I use 1 and 2, so I cannot use 1 and 2 no more. Either 1 and 3 or 2 and 3. So we decided to use equation 1 and 3. And we have to eliminate z. Now, if you don't eliminate z, the process will be very long. So eliminate the same variable twice. So we decided to eliminate z. If we multiply both sides of the equation 1 by 2 and add it to result to equation 3. So we can just say the original equation. So you can see 1 and 3, we have what? Plus z, we have minus 2z. So let's multiply the first equation by 2 so that we get plus 2z and minus 2z will cancel. So that's why here we say we have multiplied the first equation by 2. So 2 times s will give us 2s, 2 times 2y will give us 4y, 2 times z will give us 2z, and 2 times 8 will give us 16. The first equation is the same thing, so we can go back and see. Equation 3 is s plus y minus 2z minus 3. So we write the same thing. So now we combine 2s plus s will give me 3s, 4y plus y will give me 5y, plus 2z minus 2z, they will cancel each other. 16 minus 3 will give me 13. Now we can see we have 2 new equations with only x and y variables. So now we are going to combine s plus y equal to 3 and 3z plus 5y equal to 13. Then we can solve for both equations, variables, which is s and y. So here it's up to us. We can use substitution if we want to, or we can use the elimination again. If I want to use the elimination, maybe we can eliminate x. I will multiply the first equation by minus 3, multiply the first equation by 1, and I can cancel x. Or multiply the first equation by minus 5, and multiply the second equation by 5, I can cancel y, then look for x. But here we decided to use substitution. So we take the first equation, s plus y equal to 3. To find y, it's equal to 3 minus x. That's what we get. We take the second equation. Anywhere we see y, we substitute with 3 minus x. And that's what we have here. So we open the parentheses, we get 5 times 3, which is 15. 5 times minus x will give us minus 5x. Combine the like term, we get 3 minus 5x, which will give us minus 2x. Then 13 minus 15 will give us minus 2 also. So we get minus 2x equal to minus 2. Divide both sides of the equation by minus 2, which means s equal to 1. Now we go to our first equation where we substitute and we say y equal to 3 minus x. So we do our substitution. X is 1, so we get 3 minus 1, which is 2. Now I know the value of x, I know the value of y. So we can take any of the original 3 equations here, substitute x and y, and find the value of z. And that's what we did here. So we have y equal to 2. So now we say to find z, we substitute 1 for x, 2 for y in any one of the original equation that includes z. And we find that z will give us 3. If you use any of the 3 original equations, you substitute the value of s and y, you'll get the same answer, 3. So let's give it a try. So here we have 1 and 2, so s is 1, y is 2. Let's put it in our first equation. S is 1. Again, y is 2, so we get 1 plus 4, which will give us 5. So if 5 cross the equal sign become minus, so z gives us what? 8 minus 5, which is 3. Now if we take the second equation, we get the same answer. 2 times 1 is 2, and we have 2 here. So we get 4. 4 cross the equal sign become minus 4. 1 minus 4 will be minus 3. So minus z equal to minus 3. Z will give us 3. So that's the best way to solve this equation. Again, in our next lectures, we are going to solve the same system of linear equation with 3 variables, but we are going to use either determinants or matrix. So we can also solve applications involving system of equations. So let's look one example. Here we have an airplane which flies 600 miles with a wind for 2 hours, which means if the plane is going the same direction with the wind, 600 miles will take us 2 hours. And also when you return against the wind, so if we are flying at 600 miles and the wind is opposite to the airplane, then it will take longer, to take 3 hours. So now the question said we should find the speed of the wind and also the head speed of the plane. So it's up to us. You can see here we use A plus W. A plus W means the airplane and also the wind. And because it's plus, it means when they are going the same direction. So that is 2 hours. And A minus W means the wind and airplane, they are going opposite direction. So that's why we say A minus, and that will take you 3 hours. So here we say let's A represent the air speed. So we're using A as the air speed, and also W represent the wind speed, W. So we say the ground speed of the plane with the wind is the combined speed A plus W. But on the returning trip, the plane go against the wind. So it will be A minus W, and that is 3 hours. So here we write our expression here. We know the distance, again, is R times T, the time, and also the rate. So here, the R will give us, when we are going, is A plus W, and the time is 2 hours. Returning trip, the wind is opposite, going opposite direction with the airplane. So A minus W, but it took 3 hours. So here you can see that we have our equation. 600, which is the original distance for both of them, 600 miles, is 2A plus W when we are going the same direction. Opposite direction with the plane and the wind is 3 hours. So it's 3A minus W, which is right here. So from here, our main goal is to find the value of A and W, because that's what the question was asking. The question said we should find the speed of the wind, which will be the excuse me, which will be the W, and also the head speed of the plane, which will be the A. So we have our expression, we reduce it by the 2 and 3, so we get 300 equal to A plus W, 200 equal to A minus W. So we can use a substitution or elimination method, is up to us. So here we decided to use substitution. We can take or this can be elimination perfect method. Actually, we have W minus W and plus W. So let's use the elimination first, then second, we use substitution. So if you combine these two, W will cancel W. We are going to get 500 equal to 2A. Actually, that's what they have, 500. So this means A will give us 250. Now I can use the substitution. Now take any of these two equations, substitute the value of A and find W. So we decided to take the first 300 equal to A plus W. A is 250, so W will give us 50. Now here we say that the head speed of the plane is 250 miles per hour with a 50 miles per hour tailwind. And also the ground speed is 250 plus 50 or 300 miles per hour. At 300 miles per hour, the 600 mile trip will take 2 hours. But with 50 miles per hour headwind, the ground speed will give us 200 miles per hour. So that's why at 200 miles per hour, the 600 miles will take us 3 hours. Again, the main goal of this lecture is how to solve system of linear equations with 3 variables using substitution and elimination. So first, we need to start with elimination. Take any of the 2 variables, eliminate one. Take any of the 2 equations, eliminate 1 variable. Take another 2 sets of another equation, eliminate the same variable you eliminated previously. Combine those 2 equations now. You can either do another elimination if that is good or faster, or you can do substitution. Then find the value of the remaining 2 variables. When you get the answer, pick any of the original 3 equations, substitute the 2 variables values, and you can find the 3rd variable. So again, wish everybody the best. If you have any question again, send an email or we meet in class or online. Thank you.